Okay, today we're going to talk about lesson 83, factoring special products. So we've already learned how to factor some trinomials, like for instance, we've learned to factor x squared plus 5x plus 4. We'll say we've factored stuff like this before, and we've drawn the parentheses and said x and x, and we've said the factors of 4 are 2 and 2 and 4 and 1, and the ones that add up to 5 are plus 4 and plus 1. So we have factored trinomials before, but these are special trinomials and special products. So the first type is a perfect square trinomial. And it would be something like x squared plus 6x equal, no. So x squared plus 6x plus 9. And when we factor that, we get x plus 3 times x plus 3. The factors of x squared are x, and the factors of 9 that add up to 6 are 3 and 3. And if you notice, this ends up being two identical binomials. Or you could write it like this: x plus 3 times x plus 3, or x, the quantity of x plus 3 squared. So when you can factor a trinomial and it results in two binomials that are identical, that means it's a perfect square trinomial. I actually just did that problem on the page before. So this says, is it a perfect square trinomial? So is there a way that you can factor this x and x? And what are the factors of 4 that would add up to -2? So 4, 1, 2, 2, -4 times -1, -2 times -2. None of those actually this is not even factorable. So you would say this is prime, and it is definitely not a perfect square trinomial because you can't even factor this. Okay, so it wants to know if this is a perfect square trinomial. So you would say, with the first term, you would say, what is the square root of that term? And that would be 6x and 6x. And then you would say, what is the perfect square of 16? And there's two choices, 4 and 4, and -4 times -4. Now, when you have a negative in the middle, you should know that you're going to go with these last two terms being negative, or at least one of them. And now you're going to check to see if this even works. So 6x times 6x, 36x squared. Then outside times outside is -24x. Inside times inside is also -24x. And last times last is +16. Now when you add these together in the center, you get -48. So it's 36x squared minus 48x plus 16. And that is the same as your original problem. So when you factored it, you got two binomials that were identical. So you would say, yes, this is a perfect square trinomial. Because you can take the square root of the first term and you can take the square root of the last term, and when you multiply it out, it ends up being exactly how the problem started, 36x squared minus 48x plus 16. All right, so here's a problem. Application: cell phone towers. A cellular phone tower signal covers a circular area with a radius of r miles. The strength of the signal is increased and now covers an area pi r squared plus 10 pi r plus 25 pi square miles. By how much did the radius of the coverage increase? So originally, so what we'll start by doing here is, it originally was just r, but now when they, which would be pi r squared would be the area, but now they're saying they increased r by something, and when they did, so the radius is now r plus something squared e times pi. And they're trying to figure out what would result in that squared. So actually, if you factor this right here, the thing is first, the greatest common factor that you can factor out is pi. And you'd be left with pi times r squared plus 10r plus 25. And if you were to go ahead and factor this right here, you would end up with pi times r and r. And the factors of 25 are 5 times 5. And do they add up to 10r in the middle? Yes. So the original question said, what was the r increased by? And the r was increased by 5. So you say, how much was the radius of the coverage area increased by? It would be 5 miles. It was increased by 5 miles. That's a kind of a hard question there. All right. So the other, sorry. The other special product that we're going to talk about today is a difference of two squares. And how that results is if you end up having two binomials that are identical, but one has an addition sign and one has a subtraction sign. So one situation where that would occur is like x squared minus 49. So if you were to factor x squared minus 49, when you were to factor it, you'd get x and positive 7 and negative 7. And when you FOIL that out, the negative 7x and the positive 7x cancel out. So you're left with just x squared minus 49. So this is actually called a difference of two squares, because this is a square, that's a square, and that's difference. So they want to know if this is a difference of two squares. So can you take the square root of 4x squared? You should say yes. 2x times 2x. And then can you take the difference, can you take the square root of 25? And you should say yes, 5 and 5. Now, if this is a difference in the center, one would be plus and one would be minus. So yes, this is a difference of two squares, because you can take the square root of 4x squared. You can also take the square root of 25, and there's a subtraction sign in between. So when you factor it, this is what you get. And yes, this is a difference of 2 squares. All right, let's see. Can we take the square root of 9m to the 4th? You should say yes. 3m squared. 3m squared. And then you should say, can we take the square root of 16n to the 6th? And you should say yes. 4n to the 3rd. 4n to the 3rd. And since that's a subtraction sign, your end products or your end binomials would end up being one with a plus and one with a minus. So it would be 3m squared plus 4n cubed times the quantity of 3m squared minus 4n cubed. So yes, this is a difference of 2 squares. Because you can take the square root of 9m to the 4th, and you can take the square root of 6n to the 6th, and there's a different sign in between. And now I would say, is this a difference of 2 squares? So what is the square root of x squared? X. What is the square root of 8? Can you take the square root of 8 and have it be an integer number? And you should say, no, it's not possible. So you would say that this is not a difference of 2 squares. Of 2 squares. So the two important, oh wait, we have one more question. Okay. Ganesh is designing a square border around the square pond. So the part that they're talking about here is this border. The area of the pond, that's this part, is 225. Use the difference of 2 squares to write an expression that's representative of the border. So the area of this entire square, we'll say including the pond, is whatever 2f times 2f is, which is 4f squared. And the area of the pond, we already found out, was 225. So we're going to subtract that. So the area of the pond, or the entire square, is 4f squared. But for us to just find the yellow area, we would have to subtract the area of the pond, which is 225. And then it wants us to factor that. And that ends up being a difference of 2 squares, because f times f squared times, or 4f squared is 2f times 2f. And 225 is positive. Wait, how do you factor that? Oh, I know what it is. The square root of 225 is going to be 15 times 15. And since this is negative, one's going to be positive, one's going to be negative. And that would be our answer, and we would want to put square feet. So the two special products we've talked about is the difference of 2 squares and perfect square trinomial. So just to review one more time, I'll add a slide here at the end. Oopsie daisy. So perfect square trinomials would be something like x squared plus 8x plus 16. Because when you factor that, you get x plus 4 times the quantity of x plus 4. You get two identical binomials. It's the perfect square trinomial. And then a difference of two squares would be something like x squared minus 64, where x squared, you can take the square root of that and you get x, and the square root of 64 is 8 and 8. And if there's no middle term and just a subtraction, then one would be positive and one would be negative. So difference of two squares would be two binomials that are exactly the same, except for one has a plus and one has a minus. Okay, so let me know if you guys have questions on Thursday with the practice set. And I'm going to assign a couple of additional problems. It'll be posted on Google Classroom along with this video. And you can ask me questions either via email or Google Hangout chat, or on Wednesday or Thursday when we meet. All right. Hope you have a good day. Bye-bye.